namely spectroscopic force-2 data. So what I have to do first is to launch my reduction software, which is ESO Reflex. I just have to type ESO Reflex. If I type -L, I get the list of available workflows. A workflow is associated to an instrument and a mode, so I have to select the right workflow that I need. And let's see if I'm able to make a little bit bigger. Okay, so as I said, I would like to reduce force spectroscopic data. This is the workflow I would like to load. So I just have to type ESO Reflex, the name of the workflow. And then the ESO Reflex interface will load the so-called workflows. Takes a few minutes. And of course, I don't need just the software to reduce the data, I also need the data to be reduced. So I will show you how to instruct the workflow to look for your specific data and do the reduction. So what you see here is indeed the force-2 spectroscopic workflow. The workflow itself is composed by two parts. The first upper part is the so-called setup of the workflow. It gives you the opportunity to change the directories, some options, some parameters that I will illustrate in a second. And the bottom part illustrates the various steps of the data reduction. So as Wolfram explained to you before, each of these boxes are associated to a recipe or a particular task in the data reduction cascade. So the first, okay, the workflow as I loaded now, it is already set up and working to reduce the data that are provided with the pipeline installation. But this is not the data I would like to reduce. I would like to reduce my own data. So I have to modify the first part of the workflow, which is up here now. Let me zoom on it. And I have to tell the workflow where to look for the input data. So I simply double click on it and I browse. Let's see if I remember where I put my data. Yes, of course I do. Just a little bit of drama. Okay, workflow, okay. This is where my raw data are. So in this directory, I have raw data and the raw calibrations. Then these are other kind of directories and tell me where the final products will be stored. And these are other working directories and tells me where the bookkeeping, all the information about the files that have been used, the recipe parameters and everything else are stored. This is where the log of the recipes are stored. This is where the temporary products of each individual steps will be stored and so forth. Another important section here is this one on the right that tells you, that gives you the opportunity to change some of the so-called global parameters. For example, the fifth viewer here allows you to change the software used by Reflex to inspect your FITS files. The default is to use FV. I would like to use another one, DS9, so I specify the software I would like to use it, SciSoft bin DS9. So this is the program I would like to use to inspect my FITS files. Okay, and okay, and now I'm not going to describe all of them. Anyway, so now in principle, I should be ready. I should be ready to, I should be ready to process the data. So let me do a little trick here. I animate at runtime, and these little options will highlight the part of the data reduction cascade that is active. So now I just have to press play. And you see that now this part is active. And I got this pop-up window. So what happened now? What has happened? The workflow used the so-called OCA rules that were mentioned before by Wolfram to inspect the directory where my data are. So it understood which kind of files were in the directory, which kind of calibrations, and created the so-called datasets. So in that directory, Reflex identified 2 datasets. A dataset consists of a lot of files. I can inspect how a dataset look like. So I just select the first one, type inspect highlighted, and I see here what's inside that dataset. I have my science frame here at the top, and all the calibrations that are associated to that science frame and that are needed to the recipes to process my data. So as you can see, I don't know anything about bias. I don't know anything about spectra. I don't know anything about the data. Reflex did it for me. So it organized everything for me. I just know that I have this science file to reduce. Simply don't care about anything else. Okay, what I can do is, for example, inspect the file. So if I type inspect, I load my favorite image viewer, the one I selected before, and I can have a look of how my science look like. And I can inspect all the files in the dataset. So I can decide, okay, this bias is good, keep it. This bias is bad, remove it. All this kind of stuff. And here you can see folders that contain certain type of calibrations. For example, the folder bias contains the biases that are associated to my science. Here, for example, I have my standard star, and here I have the calibration that are needed to process my standard star, which will be used to calibrate my science. You can see that I have another bias directory here, because those are the biases that are needed for the science, not the biases that those are the biases that are needed for the standard, not the biases that are needed for the science. I don't want to mix calibrations. So if I would have had to organize the data by myself, could have taken a couple of days. Here, in a few seconds, I have everything organized. So Reflex knows which bias goes with which file. Okay. Other information that I can find here is, for example, the slit that has been used, the detector that has been used, the name of the target, the instrument configuration, and everything. At the end of the columns, I can inspect the night log, and I check whether the atmospheric conditions were good enough to fulfill my science goal. So if I see that those values are fine, okay, otherwise I don't reduce that data set. So this is a scientific decision that only I can do, right? Only you can do. Okay, now I would like to go on with the reduction, and let's say that I'm interested in processing just this data set here, the last one. Okay, so, and I also would like to say, okay, this is my first attempt. So now I associate a tag to this reduction. So I will recognize later on which was that reduction, because this is the tag I have associated to that. So continue. Now the highlight is here, and this is the step in which the biases are processed in order to create the master biases. And then the products, the various master biases, will go on the other recipes. Will take a few seconds to process. I didn't prepare any joke in the meantime to tell you. Okay, now the action went here, is doing the calibrations. Another set of calibrations are processed, and you will see in a few seconds the outcome of it. You might have noticed that these boxes are orange. Orange means there is a Python interactive actor in it that pops up this window. Oh, magic, what's this window about? This window allows you to inspect the intermediate products. So the outcome, the products of that recipe. So here you have a display that shows you the various files that have been produced. And here you have a list of recipe parameters. So the concept is simple. You see what has been produced. You like it, you can go on. You don't like it, you can change the recipe parameters. Okay, here you have several parameters that are associated to several steps. I don't want to enter into the details to describe all the parameters. There is the pipeline manual that tells you what is the meaning of each parameter. But for example, I just want to change this one from 10 to 9, just enter my favorite value, and I rerun the recipe. Now the recipe is re-executed with a new parameter. Takes a few seconds. Pardon? Yeah. Okay, so now these are this is the new set of outputs, and I can inspect them. Okay, now I decide, okay, I don't like these results, I prefer the previous one. So I put 10 back, and I rerun the recipe. Now I don't have to wait that long because I already processed it. So the lazy mode entered into the game. So Reflex realized that I already processed those files with that set of parameters. So it does not rerun the recipe again, simply broadcasts me the previous results. And here I have the option to inspect the various products, as I said before, the arc lines, the flat field. These are the list of detected lines, the plot of residuals, and so on. Okay, let's say I'm happy with the results, and I can continue with the workflow. So I've processed the arc and the flat fields, but you can see that still doing something. So I already processed the arcs, I already did the flats, so why is it still there? That's because I don't have only one set of flats. Remember the purpose. So there are a set of flats that have a purpose, and another set of flats that have a different purpose. So those flats cannot be processed together. So Reflex is running the recipe twice. The first time for a set of calibrations, the second time for a different set of calibrations. Because you don't want to mix calibrations that have different purposes. You want to process files together that have the same purpose. Okay. Now I continue, and I'm with the other plot. Okay, now I would like to enter a little bit more into details here. This window, this specific step of the data reduction allowed me to process the standard star. So here I have the extracted spectrum of the standard star, not calibrated. You see, just have the units is counts together with the wavelength. Here I have the response curve that has been computed by comparing this spectrum, that is a spectrum of a standard star, with a reference table. So the response curve allows you to convert EDUs into physical units. So in the bottom panel, you see the spectrum of the star, of the standard star that has been reduced. Red is the reduced spectrum, black is the tabulated spectrum. So you can make a comparison with what you got with what you expect. Red is what you got, black is what you expect. So you can really spot out that something went wrong here. Okay, so I have to do something about it. I can use these Python tools to enlarge a little bit. So I have the option really to see what went wrong, and as you can see, there are, for example, these points here that are deviating a lot from the general trend. So in a way, I have to, the first thing that I would like to try is try to not to fit these points here to compute my response curve. So luckily there is a recipe parameter that allows me to ignore some points along the wavelength. For example, and this is this parameter here, response ignore points. So what can I do? I can use this tooltip, and I can insert a region, for example, to be ignored when computing the response. So the region I'm going to insert here will be excluded when doing the comparison between my extracted spectrum and the tabulated one. So just an example. I rerun the recipe. Okay. Now, you can see that the points here have been rejected. They're blue, dark blue means rejected, not used in the computation. And you can see that the spectral region here in the blue, where things were going wrong, now they're going quite well. So let's say that I'm happy with set of parameters, and I would like to save them and use these new values that I've just discovered to be nice for the subsequent executions. So what I do is simply click here, and I'm telling Reflex to use these parameters, the one that I have specified, for the next executions of these recipes. So these need to be, this is a feature, very nice feature, but has to be used cautiously, in the sense that every time you run Reflex, if you don't, these will be the parameters that are going to use, that will be used. So you have to be aware of that. If you are tailoring a set of parameters for a specific data set, then if you click here, this will be used also for other data set, and maybe other data set will need something different. So you have always to keep in mind and trying to understand what you're doing. Okay, now go on with the workflow. And now I'm processing the science recipe. Okay, 1 second. Let me to say a few words. Okay, now the first part of the workflow has been completed. All the raw calibrations have been processed, and all the master calibrations have been obtained. Now everything is going here to feed the scientific recipe. So the scientific recipe will get the science frame and the master calibrations that I've just produced. The scientific recipe gives me the following output. Here on the top, I do see the 2D frame of my science, the wavelength calibrated. This vertical direction is the slit direction. These are long slit data. And the x-axis is the wavelength. This is sky subtracted. The horizontal lines here are the detected spectra. The science recipe has also a detection algorithm that attempts to detect sources in the field, in the field of view. It has detected 2 sources here, one up here and one up there, and one down here. Now, I mean, it's difficult to see the sources here also because the lines are cutting the signal. So what I would like to do is to change another recipe parameter that allows me to enlarge the extraction area. So I collect a little bit more signal to noise, which is this parameter here. Let's change it. I rerun the recipe. Now the results are a little bit more clear. You can see a continuum source here and an emission line source here, which is actually a planetary nebula. On the bottom panel here, it is shown the spectrum of each target. By clicking with the mouse on the spectrum, on the region up here, I can select which object to show. This is the spectrum of this object here. And if I click here, I see the spectrum of the other object. Okay, let's suppose that I would like to inspect this frame with different tools. Okay, the interactive map gives me the opportunity to make some inspections, but I would like to do something more. For example, I would like to measure the intensity of this line here, as an example. So I have, sorry, I have the list of products here, and what I can do, I can simply copy, paste the file, and I open this file with my favorite analysis tool. It can be a Python routine or something, another DS9. I can do whatever inspection I want. So the interactive windows allows me to give me the opportunity to make some inspections, but if I want to do more, I also have easy access to the files. I can open those files with whatever I want. Okay, now I continue with the workflow. The analysis is done, has been reduced everything, and I see here the what is called the product explorer. This window here gives me the opportunity to inspect all the data that have been reduced. For example, in the last hour, I have only all the data that have in my database, or I can select array, a time range. In the last hour, this is what I did. This is the data set that has been reduced. Here I see the data reduction steps I've done. Sorry, the data reduction attempts I've done. So far, I've done only one attempt. And I can recognize the attempt very easily because I can see the description. This is my first attempt. And of course, Reflex gives you the opportunity to put some music on it, and you can see here the music running. Okay, I'm a joker. My music tastes are not that sophisticated. Anyway, so here I can select the data set. This is the data reduction execution. And here I have all the products, the final products that I've obtained with that reduction. For each of the product, I can inspect the data reduction cascade. So this file was obtained by processing these files. So for each product, I can see what are the intermediate steps and the raw frames that contributed to the creation of that product. So I can, if something went wrong, I can inspect the intermediate steps straight from here and try to understand at which step the reduction went wrong. For example, I can select the file here. This is the scientific reduced long spectrum. Here I see the header information. If I right-click on the file, I can inspect with whatever software I would like. For example, okay, before I have selected DS9, so this is DS9 will be launched to view my reduced spectrum. Okay, this is the reduced one. So you can see the emission lines here. Or I can decide to inspect it with something else. Fits view in this case, and this will be opened in the back. Okay. So, or I can have my own script, my own visualization tool, whatever I want. But the point is, I can inspect all the data reduction cascade at any stage I would like, I want. Okay, now the data reduction is finished, and I can ask myself, okay, is this really what I want? Did I want to try a different strategy? Okay, fine. I press play again, and I see again the data sets that are in my raw directory. I would like to try to reduce the same data set once more with a different strategy in mind. Okay, now I put another description, second attempt. And I continue. See, now the reduction is very, very fast because everything was already processed. Okay, now I try 9. I already tried before, so this will be very fast. Okay, I'm happy with 9 and I continue. Okay, but okay. Oops. Okay, I press continue. And now you see that it was not immediate. Why? Because 9 was producing a master calibration that was never used for the standard star spectrum. So the recipe has been re-executed because it obtained a different master calibration. So Reflex knew that before it was already executed, so it didn't have to do it again. But now, because I have a different product, I need to rerun the recipe again. So Reflex knows which are the recipes that needs to be executed again, and which are the recipes that can simply broadcast the previous results. You see here the magic numbers I have introduced before. This is because I have selected, use this box for saving my configuration parameter. And the sciences take a little bit, it's not immediate because I have new calibrations. Okay, the result won't change that much, but whatever. So, okay. Now, in the last hour, let's say in the last hour, I have reduced one data set 2 times. This is my first attempt, and this is my second attempt. So I can inspect the products for every data reduction attempts that I've done. And I compare it, and then at the end, I select the best one that suits the one that I prefer. And I select the best one. Okay, well, how much? Oh, I still have a lot of time. So I would like to show you some other features of Reflex. Okay, let's suppose that I'm happy with these parameters. I have a lot of data sets that are basically with the same setup, and I'm confident enough, at least I would like to try, to reduce everything with the same parameters, launch it, go eat something, and then go back later. And I would like Reflex to do all the job for me without any popping up windows, without Reflex asking me what to do. So I would like to switch off all the interactivity to allow Reflex to reduce everything. So the interactivity is controlled by this parameter here, global plot interactivity. By default, it is set to true. Now, I know that I have selected the right parameter, so I don't need any interaction anymore. Set it to false. Yeah, of course, spelling is not my best quality. Okay. I press play. I select everything, and I go on. So now Reflex is reducing the first data set. It was never reduced before, so it takes a little bit of time. I can go eat something, and then I come back later, and I will find all the reduction already done. Yeah, John, you're right. Should have prepared some jokes in the meantime. Okay, so it simply takes. So this feature is very convenient. For example, if you have hundreds of data sets, first thing you would like to do is to process everything with default parameters. Then, so the next launch it overnight. The next morning you get all the results. You can start inspecting the results and doing sciences, which is evaluating what went well, or evaluating what went wrong, and decide, for example, which are the data sets that need a little bit of adjustment, if any.
Lodo?
Yep.
Quick comment, if you want to do that, you should also set the recipe failure mode to continue.
True. I will explain a little bit in a few seconds what Sabine just mentioned. Okay, now I have the window that tells me that data set have been reduced and saved in here. So you see 2 entries because I processed 2 data sets, could have been 100. What did Sabine just say is the following. Let's suppose, okay, now I have instructed Reflex to not to display any interactive window, so keep going. But there is always the eventuality that a recipe crash, for example. It was not true that all the parameters selected were good for everything, or one data set could have contained a flat that was saturated, I didn't notice it, and the recipe crashes for whatever reason. So among the global parameters, there is another one here that tells me what to do if a recipe fails. Ask means that I get a pop-up window telling me, okay, the recipe has failed. What do I do? Shall I stop or continue? So if I select ask or stop, then I don't get all the data. If something went wrong on the first data set, I go back to the office the next morning and I don't find everything reduced and just find a failure message. If I put this parameter to continue, then the reduction, when a recipe is crashes, then the reduction goes on and moves to the next data set. So at the end, I will get all in my final directory. I will get the products for all data sets that this reduction was successful. At least I get something rather than being stopped at a certain point. Okay, other things that I would like to show you are, Okay. I have shown you how to change the recipe parameters through the interactive windows. But as you can see, not all the recipes has the interactive option. So how can I change a recipe parameter for a recipe that is not interactive? First question. Second question, there are some parameters also in the interactive windows that belong to the recipe but are not shown to the interactive window. So the interactive windows allows you to change the most important parameters, not all of them. So how do you change the parameters that are not offered? So what you do here is easy peasy. You select the recipe that you would like to change the parameter. So you open the actor. So now I have just opened the sub workflow associated to this recipe, the master bias, and I see here the reduction loop. The recipe force bias, the one that generates the master bias, is in a loop, and it is executed for every group of biases, not for all the biases. I'm not mixing all the biases together, grouping the biases by their purpose. So the biases that have the same purpose will be processed together. Biases with a different purpose will be processed separately. This is the actor that is directly linked to the recipe. This is the reflex component that triggers the recipe and executes it. So if I double click on it, I have a window that allows me to specify the mode that this recipe is executed and also the recipe parameters. So here I can change the parameter by hand. This is the way I change the parameter in non-interactive windows. Was not? Ah, yes, of course it was not. Because I forgot to, okay, I put it to, but I forgot to tell, okay, do it, commit. Thank you. So, huh? So now if you open it again, you see that the parameter has been changed. Now I put it back to the original value because I know that the original value worked fine. Okay, since I still have a little bit of time, I will show you the content of the actors, oops, sorry, the actors that are embedded in an interactive loop. So if I double click on it, I do see all the default parameters associated with that recipe. These are the parameters that I can change during the interaction process, and these are the default values. So I can change the default values directly from here. For example, put it 9 and I commit it. So then the next time this recipe is executed, come on, come on. Come on, come on. Okay, the next time this recipe is executed, suspense. So I can stop it anytime I want. Thank you, John. True. Now it should pops up. Should pop up. Come on, come on, come on. Okay, see? I don't have the default value anymore because I have modified in the previous screen. So now the recipe has been executed with new default. Okay, I want to illustrate you briefly what's inside this box here. So if you go open actor, you see all the beauty of the loop that is behind the interactive option. You have the recipe here, and all this loop here allows you to change the recipe as many times as you want. You have a Python actor here that is the one that is generating the window. You can the window that allows you to inspect the products and change the parameters, and you loop it as many times as you want, and you interrupt the loop only when you press continue. So once you press continue, the products are broadcasted to the next step of the data reduction. So I think I have explained almost everything. There is a new feature that will be available soon and allows you to inspect existing products that are present in your system before reducing the data. And this is done here. If you double click on it, you have the option to inspect previously reduced data, yes or no. The default is no, but now I would like to put it to yes. So when I press reflex, I get immediately the description of what I have already done. So these are all the reduced data sets. The reduction didn't start, so I can inspect what I already have. You see all the attempts that I've done so far. These are my tests. The default is something that I've done the other day, 17 executions the other day. This is my first attempt of today, my second attempt. So I can check if I already did something that I was planning to do today. If I already did it, fine. I can decide whether to continue or not with the data reduction. If I already did it, I say, no, okay, I did it already, stop. Oh, yes, oh, I haven't done it, I would like to continue. If you press yes, you go back, you are both back to the dataset selection. Okay. Yep, that's everything I wanted to say.
There's one question. Oh, first, yes.
Thanks. Thanks for the great introduction for using Reflex. I never used it, and I will from now on. Could you explain the left panel that describes component data outline and what's in there?
Which one?
Well, the left panel that has on the leftmost. Perfect. Then I will be patient.
Okay.
So a couple of questions that hopefully lead in the direction for useful. First of all, when you save the parameters for future execution, and then you come out and export the workflow, are those parameters saved in the exported workflow?
Yes, let me think about it. Yes, because the parameters, when I select use these new values as new default, they will be stored.
They're written in as new defaults.
They will be written here in this list here.
Yep.
These are the defaults. So if I override the defaults, this will be written. Then if I export the workflow, it means that I'm saving it. So I will save it with the new defaults. If I close it without saving it, then I reopen it again, the original defaults will be loaded because I did not save my changes.
And can you run this in a batch mode?
Yes. So batch mode is very important. This is a test. So now let's suppose that I have identified the parameters that I would like to use. I know everything. I would like to run Reflex maybe on a remote server, and I don't want to have this interface because I don't need it. So what I can do it, I can run in the so-called batch mode. In the batch mode, I can specify with the command line all the parameters that I can specify in the main canvas. For example, here, if I do ESO reflex minus L is the list of workflows, minus T and the name of the workflow tells me which are the parameters that are used for that workflow. Then if I type, for example, where is the raw data dir? Okay, raw data dir minus no equal. Okay. Thank you. And these are all new features I still have to get used to. Okay. Okay, now let me close this one. Discard everything. Okay. Now I'm telling Reflex to be run in non-interactive mode and process the data that are inside this directory. Just have to press enter. Pardon? Sorry? It is processing. I'm not getting any error message, so it is processing. I hope so. Okay, now it is identifying the datasets. It is inspecting the directory, so it is looking what kinds of data are, so it's creating the datasets, and the processing itself will start. So with no interactive features, we no windows popping up, plain reduction. So at the end, I will check the final directory and see what I got. Here, yes, this I think there will be a message on the terminal telling me this data set has been reduced and saved here. On the terminal, I will not get a pop-up.
Thank you.
See, dataset. This dataset has been reduced and saved in here.
Just to fill up time while this is processing, I have a question about the memory. I saw right at the beginning here that there's a quick line about memory. Is that the memory needed? And I know you can change it with a command.
Mm-hmm.
Is that the memory used by the Reflex, or this is the memory that will be needed for the data? And for example, for Muse data, you would need to change that to several gigabytes, I assume?
It is the memory needed for Java to run Reflex. So it's not the memory needed for processing the data.
For the data, okay, perfect. So like on mine here right now, I have 256 and max 1 1 gigabyte, that should be enough.
It is enough for not for all the dataset. If you have a directory with a lot of dataset, it means that Reflex has to read a lot of files, create a huge tree of connections. It requires memory. So if you have a lot of data, you might want to increase that memory. However, this is not the memory needed for processing the data. For example, Muse can be, a lot of Muse datasets can be organized with just 4,000 bytes of memory, organized. But if you want to reduce them, you need, for example, 200 gigabytes of RAM. Okay, well, it will take a few time. Okay, now I'm going to eat. I will come back in a couple of days. Okay, so.
Are there any more questions? Does maybe anyone wants to comment on their experience with ESO pipelines and with the Reflex workflow, and maybe give comments on what you would like to see improve?
What about telluric correction with this peculiar force over?
The what? The telluric
correction. Yes.
Telluric correction. There will be a talk on telluric correction later. So we will cover this topic. Well, at the moment, we have a standalone tool that is called MolecFit that does the telluric correction. Is a standalone tool. However, we have a project that is aimed to implement this tool into the pipeline. And in April, the CHEMOS pipeline will be released, and the CHEMOS pipeline, a new CHEMOS pipeline will be released, and this new version will have MolecFit into the pipeline. So you can correct CHEMOS data for telluric feature, taking advantage of this MolecFit tool directly with the pipeline and in the workflow.
So one question, how easy would be to add in the other kind of pipelines, for example, in the Reflex environment? Is that
next
easy?
talk will cover it.
Sorry?
The next talk will cover
okay.
this.
Sorry.
We'll cover it. So John will show you how to. Yeah, John will show you how to modify workflow and to add a specific tool that you, for example, have developed.
Are there any questions online? No, if not, then let's go for